It was an HPP parameter. We were adding another customer ID, right? And now we were able to leak information about all customers, right? So, we announced them about the vulnerability as soon as possible. Everybody was a bit of, wow, that's bad, right? So everybody was in actual shock because they couldn't believe it. Because in general, if you compromise a CI/CD pipeline, you will find a lot of credentials, you will find a lot of access keys there, right? So that's very important. That can potentially give you the keys to the production environment. And the result of this is that now we have a top 10 called OWASP top 10 for CI/CD. So you'll find a lot of, very, very interesting attacks there on how to compromise the entire CI/CD pipeline, how to access containers, how to escape containers, how to poison code to production, and all these sorts of very, very cool things.
Hello and welcome to Dev Academy podcast, your gateway to the insights and wisdom of prominent experts and engineers from around the globe. I'm your host, Bartosz from Dev Academy, and it's my mission to help you glean insightful knowledge from the vast experiences of our distinguished guests. Each week we will delve into timeless topics in software development, focusing on crucial areas like security, quality, and design. Join us as we unravel the complexities of software engineering, offering you a practical, in-depth perspective. Let's embark on this enlightening journey together and transform the way we create and understand software. Hey Adrian, welcome to the show.
Hey, Bartosz. Thank you. Thanks for inviting me. Glad to be here.
Great. So today on the show we have Adrian Tiron, managing partner at Fort Bridge. He delves deep into web app security, preferring the server's secrets over client-side chatter when not reversing code, self-confessed gym rat chasing weights as much as chasing bugs, and a foodie where his appetite for delicious code is matched only by his love for good meals. Very poetic introduction. I love it.
Sounds good.
I love it.
Thank you
So
very much. I am a gym rat, I have to admit. In my free time, I do a bit of security as much as I can. Yeah.
I get it. So now the first thing is gym, and the second thing is some chasing bugs.
Yeah. As a hobby.
Okay, I get it. I think we will just dive deep into this more technical stuff. Before we do that, can you just share a bit of your journey in this tech industry?
Sure.
Especially your focus on web security and web applications.
Sure, of course. So, started my career roughly about 20 years ago. Now, I know you're going to say Adrian, but you still look 20, which I want to say thank you very much, Bartosz. I appreciate it. That's very kind of you. So, yeah, it was a while back. Initially, I was a software developer as part of my full-time job. But in my free time, I was always interested in security, in web application security. I think it was very, very popular back then. Everybody was, learning about SQL injection. There were a lot of exploits. You're hearing, let's say, weekly about some sort of hacker who exploited an SQL injection in a popular or in a governmental website somewhere. So, yeah, I guess the first vulnerability that I ever heard about was SQL injection, and that's what it got me started. I was very interested in learning new things. I was registered on a lot of hacker forums back home in Romania, and also some international forums, I guess. Maybe a few years later, I found out about SQL Map, which was a very, very popular tool back then, and I think it was around that time, I don't know, maybe 2005, 2008, somewhere around that time when the authors actually started creating that tool, right? And I was a software developer. So on one hand, I got to say I was interested in web application security. However, because in high school I studied low-level programming languages like C, C++, I was also interested in the security of compiled languages like C and C++, for example, vulnerabilities like Stack Overflow, Heap Overflow, and this kind of stuff, right? And then in uni, same thing happened. Really, I continued studying C, C++, and in my free time, I was reading, trying to translate what some Chinese hacker wrote on a forum. So I was using, Google Translate, and it was pretty difficult because the times were very, very different. So it was very different landscape. You didn't have a lot of courses and trainings like you have now, right? So if you're interested in if you're passionate about security, you're using whatever sources you could find back at that time. So for me, sometimes there were some white papers written in Chinese or in Korean, and I remember, using Google Translate and trying to make sense of all of that, like how you do a return to libc type of exploit, how would you write a Stack Overflow, how would you bypass ASLR and that kind of stuff. Um, However, because the security industry was just at the beginning, I continued my career for a couple of years as a web developer, and then I moved full time as a senior security consultant working for KPMG. And the main focus, basically, the main type of projects that we had was a web application security pen test or an infrastructure pen test. That's pretty much how it was, to try to keep it relatively short, right?
It's a great story. I really, really like the fact that you started as a software developer because you
Hmm.
know from the inside out how the software is built,
Hmm.
from the development perspective. And on the
Hmm.
other
Hmm.
hand, you have this penetration testing perspective, which is trying to break in. So it gives this, perspective, the
Hmm.
360 view on this problem space that we are trying to discuss today. But before we jump, I have one question which I like to ask on the
Sure.
show. If you could time travel, would you
Hmm.
travel to the past or the future?
Well, it's tough to say. It's tough to answer this question. Personally, I don't really like to make predictions about the future. It's very hard, and it's a thing that I've never tried to do in my life. Because again, during my career, maybe 10, 15 years ago, it was very, very popular question by the HR department, like, where do you see yourself in 5 years or in 10 years, right? So I had to make something up. But personally, I never really like to give estimates about what I'm going to do in the future, right? So I guess, it would be tempting to say, to travel in the future, probably to see where I'm at in 10 years. That would be one thing. And just as a curiosity, mainly, right? Because I would just be purely interested in what I would achieve in 10 years. And on the other hand, I guess it would be more tempting to travel in the past and try to improve certain things that maybe I think I could have done better. Maybe I could have, I don't know, worked more on certain things. Maybe I could have been more focused on achieving my objectives. That would probably be more interested for me personally. And maybe try to influence my future, maybe change it a bit, maybe improve it a bit. I think that would be more tempting, I would say.
Okay. I mean, when I ask this question on the show, I receive very diverse and different answers. One of the guests said that he would love to go back to the past to see dinosaurs, how the
Mm,
life on the earth looked when the dinosaurs were still alive. So
okay,
it's very interesting to see how different people approach this question. But let's go back to the main topic. We would
sure.
like to dive deep into the security for web
Hmm.
applications. And
Hmm.
let's start small and actually, what is penetration testing?
Hmm. Sure. What is penetration testing? I guess I should know the answer to this question because this is basically what I do as my day-to-day job, right? This is why certain companies are paying me for to do penetration testing for them. So, what is penetration testing? Basically, we're using our skill set in order to find vulnerabilities in our customer applications. This could be a web application, a mobile application, an API, or whatever, right? So we're trying to emulate hackers, but we're trying to do it in an ethical manner. We're trying to discover as many vulnerabilities as we can, high impact vulnerabilities preferably, which after that we disclose to our clients together with some recommendations, practical recommendations to help them fix these vulnerabilities. So yeah, we try to emulate hackers. and we pen test basic applications, infrastructure. This could be on-premise infrastructure or cloud infrastructure, because as you know, in the past 5-6 years, I would say it became very common for everybody to migrate their applications and their workload to the cloud. So we need to pen test those environments as well, and to make sure that they're as secure as possible.
Uh, that's actually how I believe would also answer this question. But if we would like to go a little bit deeper, what kinds of testing are there? Because one may say, "Oh, I have heard something like blue team, red team, purple team." How can we categorize on the lower level this kind of testing?
Sure. So from our obviously everybody will give a different answer to this question, right? So if you ask 100 people, you'll get 100 different answer. So we try to keep things simple so that everybody's on the same page. So from our point of view, we consider red team when we emulate an attacker, right? But that would also be without informing, let's say, their SOC, right? Because we're trying to see if they're actually able to detect our attack attempts or not, right? We're not only trying to find vulnerabilities in their infrastructure or in their applications, we're also testing their incident response capabilities in a red team. So that would be one main thing, right? The blue team, on the other hand, would be the defensive side, whatever they're doing in order to defend their company, to defend their infrastructure, to defend their personal identifiable information, credit card, or whatever it's important for that business. And I think you mentioned purple team engagement as well, right? So that would be an example, let's say, of a closer collaboration between our team as attackers and their team, which are trying to defend. So we would collaborate closely, and we would work to see which of our attacks they're able to detect. And if, in case they're not able to detect some of our attacks, we would work together with them to improve their detection capabilities. We'll try to understand what did they miss, maybe help them write some better signatures for the tools, or show them some new TTPs that we've applied and that they're not currently detecting that. So we would help them with that as well. Does that answer your question?
Yes, I think that show us a very interesting perspective on this, and I really like that you said that if you ask 100 people, you will have 100 different responses, because those kind of definitions are there is no book written name or definition. It's kind of like different people, different companies are trying to fit into this position in the role. But on general, I think that a lot of people would definitely agree with how you now described those different approaches. So it's, I think there is a common understanding, and on some level of degree of details in this context. So
Sure.
what kind of different vulnerabilities you usually find on the battlefield, right? Regardless
Yeah.
of if you are on this red team or a different team, but you actually start your work and you're trying to, you have your ways, right? How to start
Yeah.
and how to do this. And I'm curious, what kind of vulnerabilities you usually find?
Sure. It depends a lot on the maturity level of the client that we're working with, right? If it's a client that they don't really have a big security team, or maybe they have a large number of developers, but they don't really have a lot of, let's say, application security experts to work with their developers in order to produce secure code. Or maybe we know that they don't have a DevSecOps pipeline built yet, or it's not mature enough yet. We know that we'll probably find a lot of low-hanging fruits. We might have some injection vulnerabilities, some cross-site scripting, I don't know, maybe a command injection somewhere. This type of vulnerabilities actually happen, Or we know that we will find some old dependency like image magic that has not been upgraded in years, and that's also a possibility, that we might find. Could have happened, could have obtained an RC or two. during the past couple of years. So that's definitely a possibility. On the other hand, if we have a client that we've collaborated over the past maybe 3-4 years now, and we've been working with them year after year and doing pen tests, we know that their maturity has improved over the couple of years. We know that we will not find the same type of vulnerabilities that we found in the initial pen test. So now we have to work harder. So we have to find some logical vulnerabilities. We have to find maybe a tricky race condition that we might have to exploit, or we might find let's say, an authorization issue, but it's going to be a tricky one because we might have to use like an HTTP parameter pollution attack in order to exploit this authorization issue. So we're still going to find vulnerabilities there, but it's just getting a bit harder. It's a bit more work on our side. That's kind of how it works. If you work with the same company year after year, they will slowly improve their security game, which is normal. I think it's normal, right, for any company. So yeah, that's pretty much how it happens. Yeah, I'm referring now strictly to the more interesting vulnerabilities. I'm not talking about the common cross-site scripting, or we found a JavaScript library that is not updated on your website. No, I'm talking about like real vulnerabilities with high impact of exploitation. Yeah.
Yes, so I believe that most of the listeners are aware what those common things like cross-site scripting is, or SQL injection. But let's try to put on the table this term which you mentioned, HTTP parameter pollution. What is this kind of a problem?
Sure. That's a great question, Bartosz. Happy to answer. So, HTTP parameter pollution is a very, very interesting vulnerability from my point of view. We found some very, very interesting ways to exploit it in the last couple of years for our clients, especially in APIs, because we had a lot of engagements where we had to pen test APIs. So what is HTTP? Let me get to the point. Basically, let's say you have an endpoint of an API, and this endpoint fetches the orders of a customer, right? The orders that the customers placed on that website. And it has a get parameter called customer ID. So you give the endpoint the customer ID, and it returns all the orders placed by that customer. So what do you do with HTTP? Basically, you'll start and you will add another parameter, a second parameter with the same name, also customer ID, but now you'll give it a different customer ID. So what could happen is you could bypass the authorization checks, and now you actually get all the orders of the second customer that you just passed the customer ID. It can happen. It happened to us in many cases, and the impact is critical because now you have the possibility to leak information from all the customers of that website. And we could be talking about hundreds or millions of customers, and you will get information about all their orders together with private PII information, right? So that is a massive critical information leak. Other tricks that you can do, you can potentially change from get method to post method, and now you could add the customer ID parameter. You'll have it in get in the URL, but you will also have in the body of the request as a post parameter. So you have it in get and in post, and this could also be a way where you bypass the authorization checks. So this actually happened to us. We discovered we used these tricks quite a few times, and let's say it was a very, very nice finding for us, and it was highly impactful and also very, very appreciated by our clients. Does that make sense? Do I need to expand more a bit?
Yes, it's actually a very interesting description. So it means that it falls into this category of broken access control usually, right?
Well, yeah, it does fall into broken access control. It is a broken access control, but the cause is very interesting. It's different than, let's say, the classic cause, because the classic issue would be that the developer forgot to implement the checks, right? Well, in this case, it actually implemented. However, what happened in the framework, you triggered somehow a different path of execution. Now, as a pen tester, we did not have full access to the source code. It was a black box pen test, right? So we had a call with the developers after that when we were trying to explain them the vulnerability, and they were trying to fix it. And this is what they basically told us. They said like, yeah, this was, I think it was a .NET application. You guys managed to trigger a different code path. It was a very complex framework, as you would expect in a major online retailer, right? And they told us, yeah, you guys managed to trigger a different code path, and something was wrong there. Yeah. So yeah, it is an access control issue, but it's sometimes you just have to find a way to trigger a different code path.
Do you find any pattern in which this happens more or less often? For example, maybe other way around. Uh, does this happen to, let's say, old frameworks which are less modern, or those even which are, fresh, popping out, that are supposed to be, better? Do you see any commonalities, or it doesn't matter what kind of tech stack the company is using?
I would say from experience, I would say maybe it's more common in .NET and maybe Node.js frameworks. But to be honest with you, we do, it's not like we have a ton of information. Like this is, it's not one of the most common. It's one of the more exotic vulnerabilities. Like it's not something that you find, at the same rate that you would find an XSS or something like that. You know what I mean? So it's an interesting question, but realistically, we don't really have that type of volume of data to give you an exact answer. But it would be interesting, maybe for a company that has a lot of data about vulnerabilities, like maybe a bug bounty company, they would probably be in a better position, to say. I would expect, maybe, I don't know.
You mentioned bug bounty. I think we should talk about this more, because it's
Hmm.
something that for many people is a way of living and
Hmm.
earning money for
Hmm.
life. That
Hmm.
those are usually. Correct me if I'm wrong. This is how I can imagine this. These
Hmm.
are not, professional services companies that are ordered a service, but rather there is a general publicly available bug bounty program,
Hmm.
and
Hmm.
different people can just try to find problems, and based on the
Hmm.
severity, they are
Hmm.
getting rewarded with
Hmm.
sometimes very, very large amounts of money, right?
Hmm.
So
It
what
is.
is your take on this bug bounty thing?
Sure. So I'll try to provide my honest answer. I have to a full disclaimer, like I've never been really much into bug bounty, but I am following the phenomenon where I can. So I do have a bit of information, from this space. So let's start with, what you said, that there are people that make some nice money, which is true. What I've noticed, for example, um, people usually maybe make a big payout. Uh, but it's not something. Maybe it happens a couple of times, maybe once a year, maybe twice a year. And in order to, I think, from what I'm seeing, in order to make like a decent living from this, like this would absolutely have to be your full-time job. I think from what I'm seeing, only a very very small percentage of bug bounty hunters can make a really good living from this. This is my impression. And, I mean, I think we've all heard all sorts of news and we've read about it. There will be people that they will land a big payout. There are also people that are getting paid a lot less than what they would expect. You'll see a lot of drama on Twitter about these people complaining that, oh, I haven't received, I was waiting to be paid more. Maybe a few weeks ago, I saw a case about somebody who found a critical information which allowed him to leak massive PII information from a company, and he was not quite happy that he received only $5,000. So you could say something. Well, $5,000 might like maybe, well, it's a good salary maybe in certain parts of the world, but if you are in the US, it's not really a lot of money. You know what I mean? And it depends, like, how much time you spent finding that vulnerability, because there's a lot of competition there, so you'll have to invest a lot of time. And yeah, it's a complicated, and you have to think from the perspective of the business. From the perspective of the business, that vulnerability could have caused, a lot of damage for the business and could have affected their reputation, their revenue. It would have been in the media. Like that would have not been. good at all. So I would say, I kind of sympathize with this guy. I would say probably that vulnerability was worth more than $5,000, to be fair. And it was a big company as well. So, you have to have some luck. Maybe, depends how well connected you are with the people, with the guy who triaged the vulnerability. I don't know. I heard all sorts of things. There's always a bit of politics. So
Uh,
it's
yeah,
complicated.
yes, this is interesting take that some people who may consider trying out this way of work
Hmm.
to be really thoughtful about how this actually may end up in their case.
Hmm.
But you used a very nice term that I want to catch upon. You said
Sure.
triage. Triage.
Yes.
Can you tell us more what triage means in case
Hmm.
of security or pen testing or an issue incident response in
Of
the
course.
world of web security?
Sure, sure. I will discuss briefly about triage. It was also something that I was discussing with some clients previously. So let's say you have a tool. You're a company. You have set up some tools in your pipeline. Apologies, like some SaaS for DAS tools, right? And now you're getting back a report from the tool. Some of those findings might be real vulnerabilities. Some might be false positives. They might not be an actual vulnerability, or it might not be exploitable, or in your context, the severity is much lower. So you have to have somebody. You have to have a guy with experience in application security, in pen testing, who understands the output from the tool, from the security tool, right? He must understand. He must try to replicate the vulnerability, and he must also be able to assess like what is the actual impact on the application and also on the business, right? Could it actually compromise the application? Could it cause a lot of damage to the business, right? So this is what triage means. You have to understand what is the actual impact, and you must be honest about the feedback, because there will be, let's say, companies that they will look at a vulnerability which is medium, but they will try to inflate its severity and make it look like it's higher or critical or whatever, right? So we want to keep it real, let's say, regarding the impact of the vulnerability. So basically, this is what I consider triage to be.
Can it
Yeah.
happen that can you give us an example of a high impact like fire in the garden
Hmm.
triage situation that it has to be, I don't know, even if it's middle of the night, all
Hmm.
hands on
Hmm.
the table. Do you have such experiences?
Yeah, sure. So I remember we actually found some critical vulnerabilities, and it was on a Friday afternoon, right? It was some sort of account takeover, I think, in the reset password functionality of a client that we were testing. So we sent them, guys, look, this is what we found. We know it's Friday afternoon, but maybe you guys want to look at this, and maybe you want to decide whether you want to fix it now, or you want to postpone it till Monday morning. It's up to you, right? But as part of any engagement with our clients, we let them know that from the start, we let them know that, look, any high vulnerability or critical vulnerabilities that we discover, we will let you know as soon as possible. So this is what we promise to them, and this is what we do. After that, it's part of them to trigger the incident response procedure and do everything else that they feel is necessary on their end.
Okay, so once we have this triage, then we
Hmm.
have incident response procedures, something like
Hmm.
that.
Yes, yes.
And I bet that it actually relates to what you mentioned before, that it depends on the company maturity level how they
Hmm.
implement this kind of procedures. Am I
Yep.
correct?
Yes, yes, exactly.
So
So.
how would you describe this incident response procedures
Mhm.
from the, let's say, very immature to
Mhm.
very mature company?
Mhm. Sure. So I'm going to speak more, but I'm gonna speak from our perspective, right? Because we're on the offensive side, so we're doing our thing as attackers, and they do the incident response procedure on their end. So to give an example, things that actually happened from the past. Let's say we found that vulnerability where we were it was an HPP parameter. We were adding another customer ID, right? And now we were able to leak information about all customers, right? So, we announced them about the vulnerability as soon as possible. Everybody was a bit of, wow, that's bad, right? So everybody was in actual shock because they couldn't believe it. And they couldn't believe that, there were other customers, other pentest companies, maybe bigger companies, bigger names in the industry that, pen tested that website and they didn't find it. So the next thing was, okay, let us guys know how you did it. We set up a call. We discussed with their team, whoever they invited from their side. It was various developers, team leads, incident response people, project managers, etc. Right? So we've explained the vulnerability to them. Everybody was okay. We understood. And then they requested us to send a proof of concept, basically the request that triggered the vulnerability, together with the response that we received. So, we went back to Burp. We copy pasted the request, pasted in a text file, and then we added a dash line, and then we pasted the response as well, together with screenshot to make sure that they have everything there that they need. So now they had everything that they required to replicate it, and we shoot the email to them. And then basically they started checking the logs. They wanted to see if, okay, are there any requests? Have we received any requests that match this pattern that we just received from Forbridge? And luckily for them, there was nothing. There was nothing in their log. So in the end, it was let's say a happy day for them because nobody actually exploited that vulnerability left. So yeah, that was a good one for everyone. Good finding for us, and it was good for them that nobody actually exploited this vulnerability on their production website. That's pretty much how it goes from our side. Now, of course, there might be a more complicated case where we might have another call, which is fine. We're always there to support our clients, to make sure that they have everything they need to understand and to replicate the vulnerability so that they can fix it after that. That's pretty much how it goes, yeah.
Okay, so incident response manager on there, or do we have something like incident response manager on the customer side that is responsible for this kind of stuff?
Yeah, in general, it's the SOC team. It's somebody from the SOC team. We always have the way we work. We establish a Teams channel or a Slack channel, whatever they prefer, right? And as part of that channel, there will be our team who does the pen testing, and then there will be various engineers from their side as well, like incident response, SOC analysts, developers, etc., like whatever is needed to support us and for us to support them as well with giving the full information that they need. That's pretty much how it goes in general. Yeah.
So depending on the triage analysis output, there is a proper incident management handled later on. If it is critical, then people just jump on the call, discuss, make a proof of concept, and then decide if this is actually something that they want and need to decide on the mitigation and fixing it, right? So before we continue with our insightful conversation, I'd like to share something that I'm really proud of. The Web Security Dev Academy Bootcamp. I created this program to help developers like you deepen their knowledge in web security. If that sounds interesting, you can join our exclusive waiting list to be notified about the next launch and start receiving tailor-made security tips. This is not a usual online course, but group-based cohort training with my direct support. To join the waiting list, visit websecurity-academy.com. It's websecurity-academy.com or check the links in the description. If Bootcamp isn't quite what you are looking for at the moment, there is another way to support us. Please consider rating this podcast on your preferred platform or leaving a comment on YouTube. Your feedback is incredibly appreciated and helps others discover our content. Also, if today's conversation sparks any ideas or if you find it useful, don't hesitate to share this podcast with friends or colleagues in the tech community. Your endorsement helps us reach and inspire more developers. Thanks for your support, and now back to our conversation. I think that good DevOps or DevSecOps, when they are able to, as soon as the fix is there, deploy to production and get it over. But sometimes it's not that easy because the deployment to production is more complex,
Yeah.
and there is a downside that some may say, you know what, we will fix it, but we will be able to. I mean, I'm just making it up. We
Yeah.
will
No,
be
no,
able
it's
to
true.
have
It's
it
true. It's true.
in production maybe in 2 days. It's at
Yeah.
the earliest possible time, and then. What I'm trying to say that in this particular situations, having a solid DevOps implemented, that okay, on the other spectrum, we will have a fix in 1 hour, for example, because we know what it is, we know how to fix it. We will be able to push to prod, and everything will be cleaned in a matter of hour, right?
Exactly. No, no, that's a very good point, Bartosz. So I'll give you an example to add to what you said. So let's say if the fix of the vulnerability is relatively straightforward and it's just at the application level, right? All you need is basically a couple of developers. They would implement a couple of lines of changes to fix the vulnerabilities. And then the DevOps engineers can push that to production and it can get there in 2-3 hours, just like you said. So this is a simple, straightforward case. On the other hand, you can have a more complex scenario, and I will give you an example. Let's say there's a dependency confusion vulnerability, right? So we found something like that. There was a bypass in whatever they had implemented to prevent dependency confusion vulnerabilities, right? But we found that there were some issues with what they had there. There were some blind spots. So we reported this to them, and they were like, "Yeah, we agree. There are some issues there. Thanks for letting us know. But this is not as straightforward to fix because this involves a couple of architectural changes, right? Because what they do was, or what they need to do is they need to go to their internal repository where all the dependencies are already scanned, vetted, and approved, and they should be only fetch dependencies when they build their project from the internal repository. This was not happening, not all the time anyway, right? So obviously, this is a more complex mitigation. They had to uh, create a team of team leads, of architects, and discuss, okay, what is the best approach? We need to make sure there are no blind spots here, etc. So this is more complicated case. It's not something that is done in 2-3 hours. It's something that might take a couple of weeks, maybe a couple of months, to make sure that you have like a robust solution there to prevent dependency confusion. Yeah.
Yes, definitely. This is I like those stories from the real life when we have a guest that can give from experience the explanation or on how the situation really happened in real life. So going even deeper, you sent me a link of one of your discoveries in Concrete CMS.
Sure.
It was RCE, so Remote
Yes.
Command Execution. How can, from the developer perspective, what it was and what can a developer can learn from this particular use case on a very technical level?
Happy to talk about this. So this was a remote code execution vulnerability that I found in Concrete CMS in Concrete CMS a while ago, and discovering the vulnerability was pretty straightforward for me. But actually creating the exploit took a couple of weeks, maybe 2-3 weeks, and I dedicated maybe let's say 2-3 hours daily to actually put all the pieces together. So let me discuss step by step what was the first issue that I noticed. I was reviewing the code, and obviously I was looking at the code upload functionality, right? The file upload functionality, because that is always something juicy. That is always something that you want to test, right? Because there might be something good there, right? So okay, I noticed, okay, there's file upload. I need to test this. So let me review the code. So I reviewed the code, and the first thing I noticed is the following. Basically, as a user, you are allowed to enter a URL and then you click a button, right? So what the application does is it downloads that file from the remote server, and it should save it locally. Now, obviously, you have to have some sort of validation, right? You can't just download any executable file or malicious files or dangerous scripts or anything like that, right? So I look at the code. Okay, let me see, how do they validate this? Okay. And I notice the following thing. So first, the application downloads the file, it saves it locally, and then it does the validations on the file extension, on the file content, etc. Right? So what does this mean here? Wait a second. So first you save the file locally, and then you do the validation. which means basically that we have a race condition there. If I actually found where that file is located on the server, maybe I can save a malicious script, a malicious PHP, which is actually what I did later in the end. So I'm thinking, well, maybe I can find that malicious script that I just saved locally, and maybe I can trigger it remotely and get a shell on the server. The only thing that I need to achieve here is that I need to trigger this file. I need to find the file and I need to trigger it before it's deleted, because the application saves the file in a temporary location, but this temporary location is actually inside the web root folder. So if it's in the web root folder, okay, it means I can access it via HTTP or HTTPS. I just need to find this location, okay? And if I find the location before it deletes it, it means I just got a shell on the server. So this was the first issue that I noticed. It's obviously an issue. It's called a race condition issue. Okay, it's a race condition vulnerability. Find the file before it gets deleted and trigger it. Okay, so far so good. I have one vulnerability. How do I exploit it? So I continue looking through the code, and I noticed that the file is stored in a temporary folder, and this folder has a random name. So, okay, so how is this folder name generated? It's generated with a function called unique ID, which basically takes into consideration the seconds, but more important is the microseconds. So microseconds means that it goes from 0 to 999,999. So you have like 1 million possibilities. So I think, okay, so I need to brute force 1 million values, right, in order to find the folder name, okay? So in order to, I was thinking, okay, there's 1 million values that I need to brute force. Seems like a pretty high number if you think about it, because it would mean that I would have to send 1 million requests to the web server, right? So that seems like a lot, and it is a lot of requests, to be fair. But there is this Burp plugin called Turbo Intruder, which was written by James Kettle, and this was written for exactly this type of vulnerability. It was written to exploit race conditions, and what it does is it allows you to send a very, very high number of requests to a web server, doing some very, very smart things in the backend. I'll not get into that right now. So I'm using this plugin, and I think, okay, it was going pretty well. I think I've managed to send like 17,000 requests per second, which was quite good, because this allowed me to send about 500 to 600,000 requests in 30 seconds. So I'm thinking, okay, now I can send 500 to 600,000 requests in 30 seconds or 35 seconds. This gives me more than 50% chance of finding the directory, and 50% chance plus 50 plus, it's like a very, very, very good chance, right? So I'll take it. And I tried it in practice, and it actually worked. I was able to send more than 500,000 requests in 30 seconds, and I was able to find the name of the directory. So this is very, very well explained in the blog posts on the ForBridge blog, if anybody is interested in having a look there. So, okay, I'm like, okay, I was able to find the name of the directory. So that was good. I've won the first race condition. I've won the first race condition, meaning I found the directory name. And now the other trick that I did was the following. The Concrete CMS was downloading a script from my remote server, right? And I said, okay, I need at least 30 seconds. I need at least 30 seconds to guess the folder name. So what I did was the following. In my script that was getting downloaded from my server, I put a sleep 35 at the beginning of the script. So, which means now the script execution took more than 30 seconds. It was taking like 35 seconds plus, and it was giving me just enough time to brute force the directory name, right? So after the sleep command is executed for 35 seconds, the rest of the script, what it does, it echoes some PHP functions. It echoes basically a PHP file, right? So I have a script that is executing for 35 seconds. Once the execution is done, the output is a PHP shell. This PHP shell is going to be written inside that temporary directory, which I just guessed its name using about 500,000 attempts. And my PHP shell, I kept it simple. It was called test PHP. So I know the name of the file. I don't need to guess it. All I need to guess is the name of the directory. So I guess the name of the directory, which was the first race condition that I already won. And now I need to see when exactly the test PHP shell is going to be written inside that directory. So how do I do this? Because I don't know exactly, the millisecond when the test PHP file is going to be written there. So what I did was the following. I said, okay, I'm going to set another 500,000 or 500,000 of requests that is going to constantly search for test PHP. And once it's executed, it's going to execute my shell, right? So I'm sending the first 500,000 requests to guess the name of the directory. And then once I found the directory, okay, now inside this random directory, I'm going to keep poking 500,000 times to see when the test PHP, when my shell is getting written inside that directory. Yeah. So if you look at the blog, I'm doing a lot of requests. I'm showing the logs from access log from Apache. Basically, this is what it keeps searching for test PHP, and eventually it will find it, right? And I'm getting a shell which is executed under the Apache user. That's pretty much it. And I'm also sharing some tips at the end how to make it easier if somebody wants to replicate this vulnerability and they exploit. Because again, it
That
took
is
me a lot of time.
impressive.
Thank you very
It's
much. Appreciate
impressive.
it. Yeah. Any questions? Feel free to give me a shout.
I mean, it's very, very impressive what you just described. I was trying to, because I'm looking at this from the developer perspective. I mean, and what you were trying to come up with is very impressive. And the question that I have in my mind is, wow, so they did something random. They were quite of trying to, make this verification, validation, but they failed
Mm-hmm.
ultimately. So what in this particular case
Mm-hmm.
would be a tip for a developer, not
Sure.
from the tester perspective to
Mm-hmm.
exploit it, but
Yes.
from the developer perspective to avoid it?
Sure. I'm happy you like this. So we have a couple of blog posts that were very, very popular. This is one of them. Now, to answer your questions regarding tips, for developers, I would give the following tips. So, starting with the beginning, the first issue was that first they downloaded and saved the file locally, and then they decided to do the validation. The way you should do it actually is the other way around. Like first check the remote file, make sure it has the right extensions, make sure it matches the format that you expect, and then if it's okay, then you download it and save it locally. Now, the second tip, when you save it, don't save it inside the document root of the web server, because that was the second issue, right? Save it somewhere else. Save it in a private location. Save it in a AWS S3 bucket, in an Azure blob, whatever you want, right? But not in a location that is publicly accessible and also executable, because this sort of things might happen, right? And the third recommendation would be, of course, they try to make that directory name to be random. It wasn't, very random. It was like pseudo random, right? And as we discussed, uh, I was able to guess it with 500,000 attempts, right? It might seem much, but we took it as a challenge. We said, okay, let's see if we can make it work, and we were able to make it work, right? So I would say, every time you need a random number, make sure it's actually cryptographically random. Even if it might seem like, oh, maybe you might think, well, this is not like very security sensitive. It's just a directory name. It's not a password reset token. It's not a password or some sort of token. I would say, yeah, probably better to use cryptographically secure random numbers everywhere. That's the best way. You can't go wrong.
It's awesome. I mean, it's terrifying. I would say that what you're saying is that even if you think that, oh, I'm not doing any security related stuff, I'm not
Hmm.
doing any authorization, I'm not doing any login, I'm just, putting a file. But even in such places like that, this cautiousness about security is critical, because
Hmm.
from one way or another someone may exploit it, even if you consider this piece of the system not related to authorization or authentication, uh, like that one, right? Because
Hmm.
oh,
Hmm.
I'm just coming up with some random name for the folder, and then okay, boom, it was a one piece of the puzzle that you used in order to ultimately have a remote common execution, which is
Hmm.
deadly, right? At
Yeah,
the end of the
yeah,
day.
exactly. Yeah. In the end, you get code execution. But I think this is why we're security professionals. This is why we get paid for. We basically look at all the pieces of the puzzles and we try to make it to put it together, and we try to get a nice result back, like a code execution. This is the kind of work we do, basically, right? So to be fair, I don't want to blame this stuff on developers, because they're full-time developers. They're doing what they're paid to do. They're there to do software development. So I don't really expect them to become security experts. A lot of things have improved over the past 10 years, I would say, in software development. Like now we have everybody is aware of security best practices. They use modern frameworks to develop code, right? So, some of the classic vulnerabilities are, let's say, almost dead, like SQL injection. Of course, you'll still hear about an SQL injection here and there, right? But a lot of things, let's say, have improved in software development and secure coding over the years. But I'm still not expecting developers to become security experts, and to be able to put all the pieces of the puzzle together, like we did in this blog post, or some other blog post maybe. That's just how I personally see it. These are my expectations. I'm just trying to be realistic about it.
I mean, of course, I mean, you cannot be both the
Right.
security expert who knows all the tricks of,
Hmm.
penetration testing, um, and, well established developer, but you can try to be the best at
Sure.
both traits, right? You
Yeah.
want to be a developer, you want to be a perfect craftsman that creates
Hmm.
quality software, but you still want to push yourself up in the ladder of the skills that, okay, I want to create as secure code as I can. I know I'm
Hmm.
not
Hmm.
probably 100% sure that every time I ship something, it's going to be, you know, bug free, because there are
Yeah.
always
Yeah.
bugs and vulnerabilities. But as a developer, I want to say
Hmm.
that we want to upskill ourselves to
Absolutely. Yeah.
make more and more secure code, right? So what developer because you said something, I'm not expect developers to be always security um, professionals, but
Yeah. Yeah. Exactly.
supposing of course, but as I said, the risks and issues always will appear. But
Hmm.
what we want to, as I'm representing
Hmm.
developers,
Yeah. Of
to
course.
do is to upskill ourselves, always to make your work actually harder and harder.
Absolutely.
And we are
Absolutely.
kind of like we are kind of like a little bit on the different sides, right? But you were
Absolutely.
there, now you are here, and
Hmm.
what developer can do, actually, as I said, to
Hmm.
make life of a security pen tester
Hmm.
harder, so that he produces more secure applications. Of
Hmm.
course, you will be doing as hard as you can to find those
Hmm.
holes, to find those issues.
Yeah.
But
Yeah.
developer who has this drive, because sometimes
Hmm.
they
Hmm.
don't care, but let's say
Absolutely.
we care
Hmm.
and we want to be better at that. What can we do to
Hmm.
upskill ourselves in this case from very technical level?
Absolutely. Sure. Great question. So, like, I understand, right? Like, everybody wants to upskill themselves, which is perfectly fine. Everybody should try to work harder and to upskill themselves and do the best job that they can, whether it's in security or in development, right? Totally agree. So, I was just having a similar conversation with a client earlier, and basically he wants us to redo the pen test that we did for them last year. So one of the first things that we discussed, because he is a developer and he's also the company owner, and he wants us to pen test his product again, right? So one of the first thing that we told him was like, uh, make sure you have everything in order, make sure all your dependencies are updated, make sure you automated all the security scans and all the security checks on your side, because really we don't want to waste time, with reporting low hanging fruits. We don't really enjoy doing that kind of stuff. We like doing, this sort of stuff, like putting the pieces of the puzzle together and discover some very nice vulnerabilities, right? This is what we also like to do. We like to be challenged. To add to that, developers, they can do trainings. They can start with maybe OWASP top 10. There's a lot of free documentation online. They can try to understand the main classes of vulnerabilities that are in OWASP top 10, and then they can build on that, right? They can maybe get some trainings. They can maybe read some books, find some, I don't know, security influencers that they like, and they can start focusing. And this could be maybe they're more passionate about server-side vulnerabilities like I am. Maybe they're more interested in JavaScript and exploiting client-side vulnerabilities like request smuggling, all sorts of client-side trickery, So they can focus on that. It depends on really whatever they like, right? Some people like the server side more, some people like client side. Ideally, they have to allocate some time daily, and they have to study, they have to research, they have to understand more vulnerabilities, and this will help them eventually to write more and more secure code, right? Because essentially this is how we all learn, right? You learn from others, you learn from what you read, you go to conferences, you read whatever research other hackers published, and this is how we got here, actually, right?
I Sure. And now, can we somehow also divide on different levels between? Okay, you said server side code, you said
Mhm,
JavaScript, probably mentioning some front end, but we also have containerization, microservices,
mhm, mhm.
infrastructure. Uh,
Sure.
can we like say what different sub topics or niches in this web security we have, starting from front end and back end is the simplest
Absolutely.
classification, but there are more. Let it be containers,
Mhm,
Kubernetes
mhm.
stuff, Dockers.
Sure.
It
Yeah.
still have the same problem space in
Mhm.
regards to security.
Absolutely right. No, that's a good question. So we mainly touched about, let's say, the application level so far, right? But then you have the entire infrastructure that you need to use to deploy your applications to reach the customer. So as you mentioned, we have containers. Everybody started using containers in the last how many years? At least 6 years, maybe more. When Docker containers become really popular, and everybody started using them. Well, why? Because now you can deploy your application in a container, and wherever you deploy that container, you're sure that it's going to work. So you can no longer say, oh, but it works on my computer. No, now it actually works everywhere, right? So that's one problem that containers solve. And on top of that, you have some sort of isolation between the container and the host, and it also makes it easier to scale your application now because you can simply deploy multiple containers running the same application, right? So it helps developers a lot, and it helps DevOps engineers a lot, and it has some benefits from a security perspective as well, right? Because now, let's say, as a pen tester, let's say maybe I've compromised your application. I found this RC that we just discussed, but it's inside the container. Okay, I got an RC, but the problem is I want to get access to the host. So now I need to find an additional vulnerability to escape from the container to the host, which means extra work for me as a pen tester. So you just found a way to make my life hard. Okay, fair game, good for you. I have to work harder. So there are some security benefits as well. Now, if we have to talk about container escapes, we can start maybe it's a low hanging fruit. Maybe I can use a kernel exploit to exploit the kernel because the kernel is always shared between the Docker container and the host. So that could be one way. Or maybe I found that the Docker container is running as a privileged container because maybe your DevOps guy, I don't know, maybe he made a mistake, maybe he misconfigured, whatever reason he had, right? For some reason the container is running privileged, which helps me as an attacker to escape easier, or maybe the socket for the Docker API is exposed. So that is another way that I could potentially escape the container, right? So, it's more work for us as pen testers, but if we put enough effort, we might find a way to escape from the Docker to the underlying host. Okay. Yeah. And what else? Was there anything else that?
I would follow up with that. So you're saying we jumped into this containerization stuff and stuff that is, different subtopic. You
Yeah.
mentioned that it gives some security benefits, but on the other hand, does it open up to some other risks that are not present when you are not using containers like Docker? Because I think that on one side, yeah, we now have isolation, right? But probably things like misconfiguration may open the doors. Are there other risks when you are on the container side of development that might be potentially deadly?
Other risks when using containers. Yeah, I mean, it depends on how you use them in the CI/CD pipeline. Because the reality is everybody has started using containers, right? And also everybody is using a CI/CD pipeline in order to deploy these containers to production. So you have to look at the big picture, and you have to secure your infrastructure as well, just as we were discussing. So you secure the application, you need to secure your containers, but you also need to make sure that the entire CI/CD pipeline that you have in place is also secure, because there was a lot of attention from pen testers, from hackers on attacking CI/CD pipelines. Why? Because in general, if you compromise a CI/CD pipeline, you will find a lot of credentials, you will find a lot of access keys there, right? So that's very important. That can potentially give you the keys to the production environment. And the result of this is that now we have a top 10 called OWASP top 10 for CI/CD. So you'll find a lot of, very, very interesting attacks there on how to compromise the entire CI/CD pipeline, how to access containers, how to escape containers, how to poison code to production, and all these sorts of very, very cool things. There are quite a few very popular articles recently. There was top 10 hacking techniques published by Portswigger, which were selected from above maybe 50 techniques in total for the past year, for 2023. And there were a couple of attacks there that were focused actually on attacking GitHub and GitLab CI/CD pipelines, how to inject into actions, into workflows, and basically how to compromise the runner and get access to the pipeline. So yeah, some very, very interesting stuff, for whoever is interested in this sort of attacks, for sure.
So we have this application level and we have infrastructure level.
Yep.
Together with CI/CD pipelines, we have containers. Is there any other realm that is worth to mention in these different scopes?
Depends if you want to look at the. From my point of view, it's kind of implied. If we're looking at the way you orchestrate your containers, right? There could be various orchestration engines like Kubernetes. From my point of view, I consider this to be part of the CI/CD pipeline. Is that what you had in mind, or maybe had something else in mind? I'm not sure.
I didn't have anything in mind. I just wanted to. It was just an open question because I want to add some even more hardcore part to this.
Sure.
The physical security, because the servers are physically still located, and you also need some kind of real world security that you cannot enter the data center, because you can easily plug in some malicious USB stick and play around, or you can intercept. There's a lot of ways actually on this spectrum, because what I mentioned is that we have application, we have backend, we have front end, we have infrastructure, you have containers, and then you can even have a physical security if there is no enough effort, someone can just hide inside of the data center and intercept the network on the physical level.
Sure, absolutely. You have to, you have to take that into consideration as well. Without a doubt, I guess, companies that are still using classic data centers that they manage, that they're responsible. Obviously, they have to ensure that they have the physical security in place to protect those servers. They want to make sure an employee cannot simply steal their hard drives or inject a USB stick, just like you mentioned. So yeah, that's a fair point. On the other hand, I was more thinking about, I guess, the cloud environments that are very, very popular. And, if you go with somebody like AWS or Azure or GCP or whatever, right, then the physical security then becomes their responsibility. So it's less work for you, less work for us as well, right? It's the physical security is now, as part of the shared responsibility model, now sits with the cloud provider, right? So it's not something that we're personally concerned, or I think that our clients are concerned, because I think basically, right, they have to trust the cloud provider, right, that they will ensure the physical security, right? So
I once saw some blog post or some website where there was presented how Google data center physically secures their servers, and it was impressive how many levels of security, from big wall, cameras, the fence, the doors, the keys, the iris scan, the fingerprint. I mean, if you can think of this, I mean, how hardcore it is, what they do in the physical world as well to protect the data center. It's really impressive.
yeah, I'm sure. I wouldn't expect anything else. We're talking about a big tech company like Google, so yeah, I'm absolutely convinced that they're doing some absolutely impressive stuff regarding their data centers and their physical security. I got no doubt about that for sure. Yeah.
We have very nice coverage of the topics from the pen testing side, from the developer side, but we have 2024, and this is probably the year when we will see more and more advancements in AI, LLMs, and things like generative AI. Is there anything that you would like to mention in the security space that LLMs and things like GPTs are being more and more present?
So to be fair, I think everybody has access to ChatGPT and LLMs, right? So I think on one hand, the attackers have access to it. We definitely use it whenever we can, but I noticed that defenders are using it as well, right? So if everybody has access to it, and if everybody is using it for defense or for offense, will it actually make a big impact? Does any side has an advantage, an unfair advantage of the other? I mean, I don't know. I think it seems pretty fair to me, right? I don't. I realistically, I'm not expecting to change much because, as I said, anybody has access to it. Everybody is obviously using it. Everybody keeps talking, and right, so you keep hearing it being mentioned on the defensive side, on the offensive side by researcher or by blue teamers. So yeah, I think it's fair game. I don't think it's gonna. I don't think it gives any unfair advantage to any side. That's my personal opinion, at least.
I agree with your point, but I wonder if will we ever be on the position that what you did, for example, with Concrete CMS was quite of a complex path, and
Exactly.
I don't think, and I don't know, maybe I'm wrong, that things like ChatGPT or even more sophisticated, fine-tuned, or more advanced LLM or any other AI that we may have these days could be yet at the position to do this kind of
For sure.
discovery like
For sure.
that.
No, I agree. That's an excellent point, Bartosz. That's an excellent point, actually. So let me expand a bit on that. So 100% I agree. ChatGPT is not there yet. Like it could not find such a vulnerability and write the exploit. So that was a result of a lot of manual work and many, many years of experience and, a lot of pen testing, many, many thousands of hours of pen testing. So ChatGPT is definitely not capable of doing this type of work. Not yet anyway. But, in the hands of a skilled person, right? In the hands of a skilled person, I see it being helpful, making that person maybe faster, more agile. Help me write some script that does this brute force, for example, right? Like I did here. Help me uh, calculate these probabilities. Is this attack possible? Is it doable? In the hands of a skilled person, it can actually make that person move a bit faster, move a bit more agile. But it cannot completely replace a skilled pen tester or a skilled SOC analyst or anything like that. No, for sure.
Yes, I
It
completely
just
agree.
makes us a bit more productive. That is all what it does for us.
Yes, so we are probably at this moment in the development of AI that it is not going to replace any of the professional like you and me, but it
Hmm.
will give a huge advantage in actually improving the productivity and giving new skills. Like you don't have to right now handcraft some small snippet of code, just type a
Hmm.
prompt and you have it, right? But you
Exactly.
are the one who comes up with this idea that I need this piece of a code, I need
Yeah.
this snippet,
Yeah.
I need this
Exactly.
exploit. You
Hmm.
come up with the idea
Yes.
and you delegate this stuff to the I don't know, some LLM.
Yeah. Exactly. You're the driver. You're in the driving seat, and you give it the commands. You have to have the brain to put all the things together and get the results that you need. That's what it does basically. It's just a productivity tool in there. It's another productivity tool.
Uh, I mean, I think we have exhausted a lot of interesting cases and topics. I hope that the show is going to be interesting. If you guys are listening, just let us know if you like it. Just write a comment wherever you are listening, if it's YouTube or if it's Spotify or other platform. Leave a review, and also you can suggest another topics. And if you want Adrian to join the next session, also tell us, and I believe he will be happy to discuss another topic that you suggest. Thank you, Adrian, for today, and
Thank you
see you
very much,
later.
Bartosz. Thank you. Have a great time. See you.